Space is vast and full of wonders, a seemingly endless expanse that stretches beyond our imagination. It holds swirling galaxies, sparkling stars, and mysterious phenomena that captivate our curiosity and drive our quest for knowledge. One of these mysteries is a black hole, a region in space where the gravitational pull is so intense that nothing can escape from it. A black hole is a place in space where gravity is very strong, so strong that it warps the very fabric of space-time. Imagine a star, much bigger than our sun, collapsing in on itself under the force of its own gravity. That's how a black hole is born. From the remnants of a massive star that has ended its life cycle. Black holes are not really holes, they are not empty voids in space. Instead, they are incredibly dense objects with a lot of mass packed into a small space, creating a gravitational field that is immensely powerful. This density creates an immense gravitational pull, drawing in everything that comes too close. Nothing, not even light, can escape a black hole's grasp, which is why they appear black and invisible to us. That's why we can't see them directly with our eyes, or even with the most powerful telescopes. Black holes are invisible to our telescopes, but we can infer their presence through their effects on nearby objects. We can, however, observe their effects on nearby stars and gas, which often orbit around these invisible giants. These cosmic giants lurk in the darkness, shaping the fabric of space-time itself with their immense gravitational forces. Join us as we journey into the heart of a black hole, exploring its secrets and the wonders it holds, uncovering the mysteries of the universe. Stars are like cosmic furnaces burning bright throughout their lives. They are the engines of the universe, converting hydrogen into helium through nuclear fusion, releasing immense amounts of energy in the process. Our sun is a star, a giant ball of hot gas held together by its own gravity. It's a perfect example of a main sequence star where the outward pressure from nuclear fusion balances the inward pull of gravity. The sun's gravity is strong, but it's not strong enough to form a black hole. Instead, it will eventually become a white dwarf, a dense, dim remnant of its former self. For a black hole to form, you need a much bigger star, at least 20 times the mass of our sun. These massive stars have much shorter lifespans, burning through their fuel at a much faster rate. When these massive stars run out of fuel, their core collapses. The outer layers are blown away in a dramatic supernova explosion, while the core continues to collapse under its own gravity. This collapse creates a supernova, a spectacular explosion that can outshine an entire galaxy. The energy released in a supernova is so immense that it can briefly outshine all the stars in its host galaxy combined. If the core is massive enough, the collapse doesn't stop there. The gravitational forces become so intense that not even atomic nuclei can withstand the pressure. It continues to collapse, squeezing matter into an infinitely small point called a singularity. This point is where the laws of physics as we know them break down. This singularity is the heart of a black hole, a point of infinite density and zero volume. It's a place where space and time become infinitely curved. Surrounding the singularity is the event horizon, the point of no return. This boundary marks the limits of the black hole's gravitational influence. Once you cross the event horizon, there's no going back. The gravitational pull is so strong that not even light can escape. Not even light can escape the pull of gravity beyond this point. This is why black holes appear black. They trap everything, including light, within their event horizon. Black holes are not all the same. They come in different sizes, each with unique characteristics. The most common type is the stellar mass black hole. These black holes form from the collapse of massive stars, like the one we discussed earlier. They are scattered throughout galaxies, including our own Milky Way. Then there are the supermassive black holes. These are true behemoths, millions or even billions of times the mass of our sun. We believe a supermassive black hole lies at the center of almost every large galaxy, including our own. These cosmic giants play a crucial role in the formation and evolution of galaxies. Some scientists believe there might be a third type intermediate mass black holes. These black holes would be bigger than stellar mass ones, but smaller than supermassive ones. We haven't observed these directly yet, but their existence is hinted at by certain astronomical observations. Imagine approaching a black hole, getting closer and closer to its event horizon. What would you experience? The journey would be both fascinating and terrifying. As you approach, you'd feel the incredible strength of its gravity. The gravitational pull would become overwhelmingly intense, unlike anything you've ever felt before. The pull on your feet would be much stronger than the pull on your head, stretching you out like spaghetti. This stretching effect would be so extreme that your body would elongate significantly. This phenomenon, aptly named spaghettification, is a consequence of the extreme tidal forces near a black hole. But that's not all. The closer you get, the more intense these forces become, making the experience even more surreal. Time itself would behave strangely near a black hole. The fabric of space-time gets distorted in such a way that time slows down dramatically. According to Einstein's theory of general relativity, time slows down in strong gravitational fields. This means that the closer you get to the black hole, the slower time moves for you compared to someone far away. To an outside observer, you'd appear to slow down as you approach the event horizon, eventually freezing in time. This effect is known as gravitational time dilation. You, however, wouldn't notice any difference in your own perception of time. To you, everything would seem normal, even as the universe around you changes dramatically. As you cross the event horizon, you'd enter a realm where the laws of physics as we know them break down. This boundary marks the point of no return. What happens inside a black hole remains one of the greatest mysteries of the universe. Scientists continue to study and theorize, but the true nature of a black hole's interior is still beyond our current understanding.